So the title of my presentation is IoT Product Development Starts with Compliance Planning. As introduced, yes, I'm Clive Watts. I work for Secure Things, been here for about 3 years. I'm the Director of Product Management here. So as we've been highlighting throughout the conference, IoT regulations have been amassing, they're gathering pace, they're now becoming more applicable globally. We have the famous 13 best practices from the UK government on the left-hand side here, and the ETSI EN 303645, which is very much established set of standards within Europe. Although interesting to see the presentation from Lewis earlier on. And of course, in the US now, we've got the IoT Cybersecurity Improvement Act, which there was a talk on yesterday, which is very interesting. And all of these things are applying increasing pressure to OEMs, to product developers to do more in order to regulate IoT products. As part of the IAR group here at Secure Things, we have access to a large number of OEMs and developers in particularly, and we continually get questions from these guys about security. Particularly the most prominent one is probably how much security is sufficient security, but also how do you measure security? People are asking us what threats they need to protect against. And most of all, people are concerned about impact on their device cost, on their project timelines, and particularly their time to market. So these are questions which we're hearing every day when we talk to people. They're asking for help. They're speaking to us and saying, can we answer these questions for them? Which of course is a challenge. So we look at the 13 best practices to start with. These set out some really great goals, very established. Obviously, these have been percolating throughout the world. And each of these pieces of guidance tells us what should be achieved. So for example, number 4 here, securely store credentials and security sensitive data. That's a fantastic goal. It's really clear that that's what we should do. But the question everyone's asking us is, but how do we do this? Because the best practices actually don't tell you how to go about doing that. All they tell you is that you're required to do this. And what we're realizing is that security is still extremely new to all of the OEMs that we're talking to. These designers that we're talking to are focused on the features and behaviors that make their IoT product appealing to their customers. They're looking at user interfaces, they're looking at features, they're looking at performance. And it's clear that security design is not yet an inherent part of their design cycle. So the question I'm bringing to the conference today is, how can we help? We don't want to see people jumping off the cliff like this into security and making a mess of things. We have far too many examples of that already out there in the marketplace. Secure Things is well known for its products that address the secure manufacturing aspect of the product lifecycle. So for secure manufacturing, what we can offer is a pipeline that effectively takes the output from the production side at the OEM, on the left-hand side here, takes the application code, a secure boot manager, any configuration data, and packages that all up and sends it over to the factory, whether it be local or remote, using an encrypted transfer mechanism, and stores that data locally to the production machine and decrypts it only at the point of manufacture. So this is an established process that we have in play today. We have customers using this in volume, and it's proving to be highly popular and highly successful way of getting code, finished product out to manufacturing and into devices without the code being modified, stolen, anything like that. But increasingly, we're looking at how we can secure the design from the outset as well. And in this case here, what we need to do is, of course, to look at some compliance planning before we start the actual design process here. So on the left-hand side here, we can see someone who's actually looking at what is required for security, how it's going to be achieved in the product, and then passing those security requirements over to the OEM designer so he can take these into account in his design process. And compliance planning, well, we touched on this a lot yesterday. Hopefully most people have already read the compliance framework that the IoTSF has put out here. But just to remind everyone, from our point of view, compliance planning means looking at what class of compliance you want to go for, how much security is enough security for your product. And that's kind of a business decision largely, but it also depends on the customer base, who you're selling products to, the type of product. And then following from that is the process of actually assessing your product design against the requirements that you've set out for your target product and audience. And of course, the planning framework that's been put out is a great guide to how to do this, and will help people measure themselves against the compliance class that they aim to achieve and the requirements assessment that they've done, ending up with a compliance report. So we've been looking at how to link all of this together here at Secure Things. And so on the left-hand side here, we've just been talking about the secure design process, the compliance planning, and then the design leading into the design process and prototyping within the OEM. And on the right-hand side here, we have the secure manufacturing process that we looked at earlier on. The planning for production, moving from prototyping into production, and actually the volume production that you need at the end of the day to get your product out there and shipping in volume and making money for your organization. And what we're working at is how you link all of these activities together so an OEM has a flow all the way through from their initial compliance planning, through design and prototyping, production and volume production. And we believe this is the way to ensure that there are no gaps between these individuals who are working on this flow and the information that flows between these different phases. Of course, the IoTSF compliance framework is the go-to document to start with for this. We've looked extensively at release 2.1 in terms of how that applies to our business and our product lineup. Of course, we're aware that V3 is coming, had a presentation on this yesterday, and we've made significant contributions to that V3 to make sure that it is the best document it can be at release. And of course, as mentioned earlier, the two aspects of this are the framework documentation, which helps OEMs understand the compliance requirements, and the framework questionnaire itself, which can be used to self-assess against the framework for a particular product design and a particular marketplace. When we came to look at this, we looked at the 15 areas in the compliance framework and looked at what, as a tools vendor, as a software platform vendor, we could actually do to help customers with this. Some of the aspects that are covered there, for example, like business and security, business policy and responsibilities, there's very little that we can do directly to help, but there are clearly multiple areas as a tools vendor, like device hardware, device software, that we can directly help impact the compliance and design process. And we'll have a look at a couple of these as we go through the presentation today. So the way that we think this is going to work and that we are working on producing for our customers today is to be able to map the output of the compliance framework directly into the design and development process. As mentioned earlier, the compliance framework is great for producing your compliance report, but there's still a bit of a question as to what we do with that compliance report now that we have it. We, as IAR and Secure Things, produce a product called Embedded Trust. Hopefully many of you are familiar with that, which is designed to be able to help customers design security into their products from inception to prototype them and move them to final production. And the link here that I'm highlighting is a feature that we have called a security context, which allows you to design security into the beginning of your design process by specifying what levels of security, what security features you require out of your development. And we're linking those through to the output of the compliance framework process so that one directly feeds into the other. So let's have a little look more at what the security context here is about. So this is the very first stage of the design process using Embedded Trust. Sometimes I'll refer to that as ET for brevity. And we've given customers, OEMs, the ability just to pick some easy decisions, to make some easy decisions as to what kind of security they'd like in their products. So for example, at the top of the list here, we've got production control and IP protection. This is to allow OEMs to limit production at their remote, often contracted out manufacturing plants, and particularly to protect their IP. And very importantly, in the middle here, highlighting here, we've got the ability to add an identity into the product, a unique identity for that product. And we've heard from many of the presenters over the last couple of days how critical that unique identity is, not just the MAC address from the wireless interface. So really, this is a very simple process for customers to just decide how to implement security in their products. And the security context is the key as to how that information is set up and recorded and fed into the development process. I've picked out 3 examples here of how we can help with embedded trust to meet the objectives of the compliance framework and the choices that an individual OEM has made using that framework and assessment for their particular products. The first one here relates to device hardware and physical, section 2.4.4, for those of you that know the document well. I've picked out 4 things on the left-hand side that are really critical for security. And of course, this one is focused around the use of a secure boot manager. And our embedded trust tool will generate a secure boot manager for your project. And there are 3 key features here of this which relate to the requirements. The first of all, this is an irrevocable hardware-based secure boot software. This applies to all classes that might be considered. We can make this a measured irrevocable secure boot manager. And of course, we can make sure that this is enabled by default. And those last 2 obviously go up the class scale from class 2 and above to class 3 and above. So you get this out of the box with embedded trust. We will generate you a secure boot manager, which is designed and tied to your particular hardware platform. And you can take that on as source code and modify it for your own requirements as the project develops. The second example I have here is on the device software category, which I think is 2.4.5, not what I put on my slide there. And this is around, of course, being able to ensure that the software images that are going into your product and being later updated, that you can trust these. So our embedded trust product will deliver digital signing of software images, and it will prevent the loading of unauthenticated software. This is absolutely critical. Many of the examples that Ken put out there earlier rely on loading new software into products that then enables them to be taken over and used for unauthorized purposes. And also, very importantly, products, of course, need to be maintained, and embedded trust will also deliver you a verified software update process, because software updates are critical to ensuring new features are delivered to customers, but of course to making sure that security is up to date in products. And underpinning all of this lot is the requirement to deliver an encrypted channel for all updates. And this is not only during the manufacturing process, but also for all in-field updates. Because at any point during the product lifecycle, there is a possibility that invalid software may be loaded, and then an unencrypted, unauthorized channel may be used for that purpose. And the third one I want to look at here is 2.4.9, encryption and key management for hardware. So the requirements are that we store sensitive unencrypted information in a tamper-resistant location, first of all. And embedded trust will help OEMs to take advantage of any secure enclave that's available in the target device. Of course, not all microcontrollers and devices have this capability, but where it exists, we want to be able to take advantage of that and to use that to protect sensitive assets. And in embedded trust, through a single click in the design process, we can enable the use of that secure enclave for development. And importantly, no controls are required, no management is required during the production process to enforce that implementation. The second thing here is that the cryptographic keychain used for signing production software is different from that used in test and development. And we have this baked into the embedded trust product, which enforces rigorously the separation of development and production keys, so that we never have a product going out the door that has keys that have been exposed to the development team and used within the development environment. Just taking this third example a little bit further, Just wanted to give you an example of the kind of partnership that we've been making. So this is looking at a device from NXP. As you might imagine, we work very closely with all the semiconductor vendors. NXP is one of our main contacts, of course. In their LPC55 series of devices, they put a lot of security into the device, highlighted here in red. And customers that we're talking to often struggle to know how to use these features in their design. And we've been trying to work out how we can help achieve successful use of these kind of features. In particular, this device here has an SRAM PUF, physically unclonable function within it, which can be used to generate, store, and reconstruct keys, and is also used as a hardware store for sensitive assets. And what we've been able to do in the Embedded Trust product here is to make the use of this physical unclonable function an absolute piece of cake for developers. You can see here in the center of the screen here, we have a dialog box, which is setting up the security context, in particular the way that the Secure Boot Manager works. And you can see here we have an option for protecting provisioned data, matching exactly the requirements from the framework. And all a developer has to do is to say, yes, they would like to enable protection of this provisioned data, select this option, and they will deliver in the final product that protection for them as a baked-in part of the product design. You can see here when we go through the build process of this product here that we've got confirmation that protection of provisioned data using encryption and authentication has been put into the product, so the OEM can be confident that that facility is available to them and will be delivered in their product. And how does this materialize in the end product? Well, here we have an example for the same part. This is one of the evaluation kits from NXP. Some of you may be familiar with this great product. What I've shown you here in the center of the screen is the debug output from the Secure Boot Manager as this device powers up. And you can see here that the Secure Boot Manager is confirming that all of the provisioned data, all of the security assets in this device are being encrypted and actually saved inside the PUF feature of this microcontroller. Of course, this is debug mode here. You wouldn't normally see this in a shipping product here. So drawing to a conclusion here, what we're trying to do with Embedded Trust and our complete tool chain is to bridge the security gap for OEMs between the output of the compliance framework, which of course is very critical for analyzing and assessing what security should go into a product, and our tool chain Embedded Trust and downstream through the life cycle, so that there is no longer a gap between those two things. And OEMs can move directly between the compliance framework assessment into design and development, knowing that they are implementing features that they've identified directly out of that compliance framework. And we are shipping today a product called the Compliance Suite, which marries these two together, a shrink-wrap security solution for OEMs to ensure that their compliance with the framework and onward beyond that to legislation for IoT applications. We've created some supporting videos for this session. One is a more in-depth look at Embedded Trust, how this works, runs for about 15 minutes or so. And we've also created a video which is about the prototyping aspect of this as you move towards volume production. Runs for about 10 minutes. I think these will be available in the hub, the content hub, after the conference closes. And you may also care to go and look at an important area of cloud onboarding, where we've created a brand new video to go with our announcements in this area about how to do secure onboarding for IoT, which is becoming an increasingly more important, very important aspect of getting devices out into the wild and successfully connected to the cloud without being compromised. So thanks very much for listening to the presentation today. Hope you found it useful. A bit of a different aspect on IoT security from a lot of the other presentations, and I'd be happy to take any questions.